Practice final. All right, let's jump right into it. We need to solve this 3x3 system of equations, and we're going to use linear combinations to eliminate certain values. So the question is, which one do we want to eliminate, x's, y's, or z's? Now, since I see a regular z right here, it's a negative z, but I'm going to go with eliminating z's first. How am I going to do that? I want to multiply this negative z by 2. That way it'll eliminate with this positive 2. So let's do this. Let's put parentheses around the bottom one, and let's put times 2, and let's put parentheses around the middle one. Actually, we don't even need to put parentheses because we're not going to do anything to the middle one. So the bottom one we're going to multiply by 2, and let's do that. What is 2 times negative 5x? That's negative 10x. What is 2 times 3y? That's positive 6y. And 2 times negative z, that's negative 2z, equals 2 times negative 17. 2 times negative 17 is negative 34. And we said that the middle one, we're going to just keep it exactly the same. Negative 3x plus 5y plus 2z equals negative 27. So we've already modified one equation so that the z's will cancel. So now we're actually going to combine and cancel those z's. So we end up with negative 13x plus 11y, z's cancel, equals negative 61. So what we call this our new equation number 1, ladies and gentlemen. I'm going to put n, new equation 1. Okay. So we need to come up with another new equation that only has the same two variables, just x and y. We want to eliminate z's. So we go back to the system of equations. We use the one we have not used yet. Which one have we not used it yet? We haven't used this top one. Okay. And we want the same variable z to cancel. So we have a negative 5z up here. So we need to either modify this one or this one to get that negative 5 to cancel. But of course, we need a positive 5 to cancel with this negative 5. So I'm going to change this negative 2z to a positive 5 by multiplying this entire bottom one by negative 5. Okay, so if I multiply this negative 1 by negative 5, it'll be positive 5, and it'll cancel out. So you could use whatever notation you want. I am going to underline this guy and draw an arrow this way, and I want to put multiply by negative 5. That's what I want to put, multiply it by negative 5. That way I get my new equation, which will be, start multiplying through here. Negative 5 times negative 5 is positive 25. Negative 5 times positive 3 is negative 15. Oh, wait a minute. 25 is with the x, 15 is with the y. And negative 5 times negative z is positive 5z. And negative 5 times negative 17 is positive 85, I believe. Use a calculator so you don't mess up. So I've modified the bottom equation by multiplying it by negative 5. We're going to now combine it with the one we have not used. That way the z's will cancel out. So let me rewrite this top one right below. Here we go. 2x plus 4y minus 5z equals 18. And now we're able to combine the lines, get the z's to eliminate. 25 plus 2 is 27 of those x's. Negative 15 plus 4, that's negative 11 of those y's, equals 85 plus 18. I just did that on the calculator to be safe, 103. And this is what we call our new equation number 2, ladies and gentlemen. New equation number 2. So what we're going to do is take this new equation 1 and this new equation 2 and put them together to form a new 2x2 system so we could actually solve it. See, the goal was to get the same letters, x and y, x and y. So now we could create a new 2x2 system. I want to write this top equation right here. I want to write the bottom equation right there. There's the top, and the bottom one's going to be 27x minus 11y equals 103. Now, this is a new 2x2 system that we need to solve, and right here in this particular case, we got lucky, because even though these equations are ugly, the positive 11y and the negative 11y will cancel out immediately, so you don't have to modify anything. But I do want to let you know that maybe on the test, you will have to, maybe you'll have a positive 22 up here, so maybe you have to multiply this bottom one by 2. That way it'll become a negative 22 that cancels with a positive 22. Or you might even have to modify both equations. So don't think that it might be, it might be this easy, but you always got to be prepared for something more challenging. Right here, luckily, the 11y and the negative 11y cancel out. So let's combine negative 13 plus 27, that is 14 with an x, equals 103 plus negative 61, or 103 take away 61, that's 42. So luckily, 42 divided by 14 is 3. So we have one answer. Now remember, we're solving a 2 by 2 system, so we need to find the x value of this 2 by 2 system. So once you have one letter, just plug it in to any equation you want in the system to find the other. So let's plug in our 3 into that x right there. X equals 3, there's x, let's put a 3 right there. So let me rewrite that top equation of the new 2 by 2. Negative 13, but instead of x, I put parentheses and I'm plugging in that 3, plus 11y equals negative 61. So when I multiply this through, negative 13 times 3, that's negative 39. We have a plus 11y equals negative 61. So continuing, we're going to add 39, and we will get 22, ladies and gentlemen. So we end up with 11y equaling 22 negative. So we got lucky right there as well. Divide by 11, y equals negative 2. There's one answer. We already had the other answer, x equals 3. We have two answers so far. So now that we have x and y, let's plug x and y back into the original to find z. Okay, so you could do it to any equation you want. I'm going to go with the top one. Why? I don't know. I'm just doing the top. You could plug it into any equation you want. So 2x, 2 parentheses, plus 4y, 4 parentheses, minus 5z equals 18. So we are plugging in the x value of 3, the y value of negative 2, and now let's do some math. 2 times 3 is 6, 4 times negative 2 is negative 8. We still have a minus 5z equaling 18. Combine 6, take away 8, that's negative 2, minus 5z equals 18. Let's get rid of the 2 by adding 2 to both sides, plus 2, plus 2. We have a new equation, negative 5z equals 20, which would mean that your z value, when you divide both sides by negative 5, your z value is negative 4. So our answer to this entire 3 by 3 system, and it did take a very long time, I apologize. The answer is, you're going to do an ordered triple. Your x value is 3, your y value is negative 2, and your z value is negative 4. So 3 comma negative 2 comma negative 4. That's your answer for number 1. By the way, on the final exam, they are not going to give you all 3 values. Why wouldn't they give you all 3 values? Because you could just then plug in the 3, plug in the negative 2, plug in the negative 4, and see if it actually works, see if it actually works, see if it actually works. And you'd be able to eliminate the ones that don't work, and you'd be able to find the answer that way. So on the final, they're just going to say, here's a system of equations. Just find the value of y. Now, in order to do that, you need to solve everything. You need to know your x, your y, and your z. So you need to be able to answer whatever they ask for, okay? Here's another one. Now this one's a little easier. Why is it a little easier? Because of this guy right here. This equation only has one variable in it. What does that mean? You could solve that one single variable equation, and you're going to get y equals negative 6. And ladies and gentlemen, we have one answer of the 3 already. Okay, so we have the answer y. We still need x and z. The question is, how do we do that? Well, instead of going with our normal new equation 1, new equation 2, we just found an actual answer, y equals negative 6. What we could do is take the answer -6 and plug it into y of the one we have not used and plug it into y of the other one we have not used, and guess what will happen? The new top equation is no longer going to have y. It'll just be x and z. The bottom one will no longer have y. It'll have a number, and it'll just have x and z, which means you're going to be able to have a 2x2 equation, an equation that has x's and z's and an equation that has x's and z's. So let me demonstrate. The top equation, 4x plus 2 times, that's going to be a -6 because we just found out that y equals -6, plus 3z equals 7. So let's do some math here. 2 times -6, that's -12. So how about this? I'm going to scratch it out, put -12, and then I'm going to get rid of this -12 by moving it over to the other side. So I'm going to add 12, add 12. I hope I didn't confuse anybody with that. So my new equation with only 2 variables will be 4x plus 3z equals 19. Now let's do the same for the bottom one. Okay, this bottom equation, I want to rewrite it. -2x minus y, but instead of y, I'm plugging in the y answer, which is -6. So this is already going to be a +6 right here. And minus z should be at the end. So let me write that down. Minus z equals -3. So I need to get rid of this +6. So I'm going to subtract 6, and my new equation should read, let me actually show my work here. Subtract 6, cancels, subtract 6. My new equation will be, I want to write it up here, -2x minus z equals -9. So what we have here, guys, is a new 2x2 system. Let me again reiterate what I did. I identified an equation that only had one variable that you could actually solve. I solved it. I got an answer, y equals -6. I got that answer of y equals -6, and plug it into the y values. That way there's going to be no more y's. It's a number that we move over to the other side of the equation, and we end up with simple equation, or actually not simple, but 2 variable equations, x's and z's. You see this top equation, it became a simple 2 variable equation. The bottom one, after substituting y and moving it over, you got this new 2 variable equation. So now we have a new 2x2 system that we can solve. So let's kind of ignore everything else and focus in on solving this 2x2 system. I am going to erase this to get more space. I'm going to multiply the bottom equation by 2. That way the x's will cancel. So the top one's going to stay the same. There it is. And the bottom one, when I distribute the 2, you'll get a -4x, you'll get a -2z, and you'll get a -18. And now we're able to combine the lines, eliminate the x's. You get 1z left over. You don't even need the 1. Let's actually erase it. Just call it z. Z equals 19 take away 18 is 1. So there's your answer right there, z. So we have z. We still need x's on this 2x2. So take that z and plug it in anywhere you want. I want to take the z value of 1 and plug it right into this z right there. So let me rewrite that bottom equation. -2x minus, I want to plug in the 1 right in the parentheses, -1 equals -9. So this is a -1 right here. How do we get rid of that -1? By adding 1. We do to one side, do to the other. You're going to end up with -2x equaling -8. When you divide by -2 on both sides, you will get your final answer, x equals +4. So we did get all 3 answers. The answer is, the ordered triple. Your x value is 4, your y value is -6, and your z value is 1. I hope this helps you solving 3x3 systems. Let's move on to describing the translation of the following functions. So in order to remember or to understand how to describe translations, we need to remember any type of like absolute value function or vertex form. I think vertex form might be the easiest to remember. What was a vertex form? It was y equals a parentheses x minus h close parentheses squared plus k. let me actually put the k in red also. We call this vertex form because your vertex is your coordinate h and k. Now, what does that really mean? That means that your parent graph ultimately gets shifted h units either left or right, but you have to think opposite of what you see there, and k units up or down, and you take that for what it is because it has a plus sign. Okay, so this is the general format. It doesn't matter if you're dealing with the parabola or even if you're dealing with an absolute value function. Y equals a, absolute value, x minus h, close absolute value, plus k. See how it's the same exact format? Technically, it even works with square roots, with cubic functions. So like if I were to look at a square root function, y equals a square root x minus h plus k on the outside. So here's the deal, guys. I know there's no square root functions here, but here's the deal. H is always going to be inside parentheses or absolute values or square roots. It's always going to be inside grouped with x, and it's always going to be subtracted from x. So that's why we always think opposite on h. Now just remember this. H is your left or right shift. K is your up or down shift. And you have to think opposite on h and take k for what it is. So when we look at the f of x function of the absolute value of x minus 2, this is obviously your h shift. And remember, you have to think opposite of what you see here. So your h is really 2. So what we say is, and positive 2 for that matter, so what we say is this one got shifted 2 units to the right. Okay, why to the right? Because we're thinking opposite, and the h shift is left and right. The k one, if it were out here, it'd be up and down, and you take it for what it is. So because right here the h value is positive 2, you're going to say 2 units to the right. Right here, is this an h value or a k value? Well, it's outside at the end by itself. H would be in parentheses with x. It'd be in here. So there's no parentheses around here. That means that your h value is 0. It doesn't shift left or right, but it does have a k value of positive 5. So right here we're going to say it shifts 5 units up. Okay. Is this a h or a k? This is a h. Okay, so that's 3 units, but you have to think opposite of what you see here. So you're going to say h is negative 2. So that's where we say 3 units to the left. Okay. And again, this one's k. It's minus 9. You take it for what it is. K is up and down. So right there we say 9 units down. This next set of questions is pretty awesome. I like them. It says, write the quadratic equation with the given roots. What are roots? Roots are answers. So they're telling you, hey, the solutions are 2 and 3. The answers are 2/3 and negative 5. The roots are negative 1, 6, and 8. Remember, solutions, answers, roots, x-intercepts all mean the same thing. Anyway, and they want you to write the equation in standard form where a, b, and c are integers. So let's write down what we know and work backwards from that. On number 7, they're telling us that the answers are x equals 2 and x equals 3. So if we had a quadratic equation, how would we solve it to get the answer 2 and 3? Well, we would factor it, and then we would split it with a zero product property, and then we would solve it. So this is kind of like working backwards. We have the answer. The question is, what binomial did these answers come from that were set equal to 0 with the zero product property? So you would have to subtract 2. You'd have the binomial x minus 2 equals 0. And over here you would subtract 3. You have the binomial x minus 3 equals 0. So imagine we're doing zero product property backwards. Instead of splitting them and setting them each equal to 0, let's put them together. Okay. So if we put them together, we're going to have x minus 2 times x minus 3. And yeah, we could set that equal to 0, but we're not trying to solve. We're trying to come up with the equation that gave us the answers. So let's distribute and get that answer. X times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. And negative 2 times negative 3 is positive 6. and we could still simplify by combining the middle terms. So we have x squared minus 5x plus 6. Ladies and gentlemen, this is the quadratic trinomial equation if you set it equal to 0. Or perhaps on the multiple choice, it'll be set as f of x equals. So they might write it as f of x equals, or they might write it as x squared minus 5x plus 6 equals 0. Either way, this is the equation that if you were to factor, split, and solve, will give you the answers 2 and 3. Let's do the same for the next one. The next one's a little more interesting because you actually have fractions. So we have x equaling 2/3, okay? And we also have x equaling -5. So the -5, that one's easy. What's the binomial that gave you the answer -5? That would be x plus 5 set equal to 0, right? So there's the binomial x plus 5. The other one's slightly more tricky. All you got to do is make sure you get that, well, you get 2/3 to become 0. And the way to do that would be to work it backwards. How would you get rid of the fraction, first of all? By multiplying both sides by 3. That'll cancel it out. So you have 3x equals 2. And then now you'd subtract 2 to get it set equal to 0. Subtract 2, and you would rewrite your binomial as 3x minus 2. There's your binomial that's set equal to 0. So now let's put both of these binomials together and multiply them to get our quadratic trinomial that if we were to solve would give us these two answers. So let's put them together. We have 3x minus 2 times x plus 5. Let's distribute. 3x times x is 3x squared. 3x times 5, 15x. Negative 2 times x, negative 2x. Negative 2 times 5 is negative 10. Combine the middle terms, and we will get our answer, our equation. 3x squared plus 13x minus 10. You could set that equal to 0, or you could put a f of x right in front of it. But this is your equation that if you were to solve would give you these answers. Think about it. If I asked you to factor this, you would have to say, oh, a times c, get a number, then make a list of that number, think of the multiples that combine together to give you the middle value 13. And if you factored correctly, you would end up here. And if you were asked to solve, you would split them and set them each equal to 0 and get those two answers. Last one. Let's do this. So we have x equals negative 1/6, and we have x equals 8. So we're going to get rid of the fraction by multiplying both sides by 6. That'll cancel out. We will have 6x equaling negative 1. Now we're going to add 1 to both sides to set it equal to 0. That way we get our binomial, 6x plus 1. If you set that equal to 0, that will give you the answer, negative 1/6. And the other one, if you add 8 to both, or subtract 8 to both sides, you get the binomial x minus 8. If you set that equal to 0, that would give you the answer x equals 8. So anyways, there's your binomial. We need to put both binomials together. So you have 6x plus 1 times x minus 8. Let's see what happens here. 6 times x, 6x squared. 6 times negative 8, negative 48x. 1 times x is positive 1x. 1 times negative 8 is negative 8. Let's combine the middle terms, and we will have our quadratic trinomial answer. So our equation will be f of x equals 6x squared minus 47x minus 8. If you solve this equation, either with the quadratic formula or by factoring, splitting, and solving, it would give you the original, or the answers, negative 1/6 and positive 8. Let's move on. Really fun stuff. Number 10 and 11. State the piecewise function represented on the graph above. Now these piecewise functions, luckily, they're all linear equations. So we need to remember how to write a linear equation. A linear equation is in the form y equals mx plus b. And to write an equation, you need two things. This is called slope-intercept form equation because you need two things to write this equation in slope-intercept form. You need the slope and you need the y-intercept. So let's take a look at all these three lines. And since we're going to be writing organized, let's look at these three different graphs from left to right. Okay. So this first line right here, we need to pretend that it extends all the way this way. Okay. So I'm going to do this green color dotted line, even though it doesn't extend this way. I want to extend it this way. That way I could identify my y-intercept. My y-intercept is going to be at -3, and my slope from one point to the other, looking at it from left to right, is down 1 over 1. Okay, down 1 over 1. So my slope is -1 over 1, which means that my slope is -1, and my y-intercept, when I extend it, as you could see, would cross at -3. So what's this equation? It's going to be y equals the slope, which is -1 over 1, x, plus b, which is -3, because the b value is where it crosses the y-axis. So there's my equation in slope-intercept form. Again, you need two things to write an equation of a line in slope-intercept form. You need the slope, which is down 1 over 1, down 1 over 1. So the fraction -1 over 1, you could just put a negative sign in front of the x. That's the slope in front of the x. Then the b value is where your line would cross the y-axis, and it would happen to cross at the location -3. That's why there's a -3 right there. Let's do the same for this middle term, okay? So we have this middle line. What's the slope of this middle line? Well, how much do you rise? It's not 1 over 1. It's actually 2 over 1. So the slope is 2. Up 2 over 1, you're just going to write it as 2. So you're going to have y equals 2x so far, and the b value is 1, okay? So y equals 2x plus 1. Y equals 2x plus 1. Again, the slope is a number in front of the x. You actually went up 2 units over 1 unit. So that's why 2 over 1, you just leave it as 2. Crosses at 1, that's why the b value is 1. Let's do this last one. This last one I want to do in black. What is my slope? Well, I go down 1 over, nope, that didn't work. I go down 1, 2 over 1, 2, 3. Perfect. So my slope is -2 over 3. Why -2? Because I'm going down 2 instead of up 2 as I look at it from left to right. So down 2 over 3. So you're going to have y equals down 2 over 3. That's the slope's always in front of x, plus your b value, which is where it crosses your y-axis. Where does it cross your y-axis? At -1. So I have my 3 equations. That's the first part of writing a piecewise function. Now, notice we have y equals this stuff. We have y equals this stuff. We have y equals this stuff. So I'm just going to write f of x, which represents y. And I want to put this like funky little bracket thing. And we're going to describe this first one. Right here's the y equals. What does this say? It says -x minus 3. So let me write that right here. -x minus 3. Now, we need a condition, though. Like this, the y equals -x minus 3. That's the entire line that goes on forever. But we know that this line doesn't go forever. It's actually cut right here, and it goes to the left forever. So with regards to our x values, we're at the x value of -1. See that -1 right there? So where is this graph at? Is it over here at x equals 0? No. Is it at 1? No. Is it at -4? Yeah, it would be up here. Where does this graph begin? It begins at -1, and it goes to the left. So it begins at -1 and goes to the left. What would that mean? That x is less than or equal to, because it's a solid dot. So on this red line, we're going to put if x is less than or equal to -1. That's the condition. That's the piece of this line in this piecewise function. So again, the piece is from the x value of -1 to the left. That's where this line, that's what we see of it. We don't see it to the right. We only see it to the left. So that's why we put x is less than -1, less than or equal to -1. Now this blue one, it's going to go in the middle. Y equals, I'm going to put 2x plus 1 right here in the middle in blue. 2x plus 1 right in the middle. And then we're going to put the condition if. Now this is the interesting one, because this line doesn't go to the right. It doesn't go to the left. It's between here and here. And let's talk about x values. Between which x values? Between your -1 and your 0. Open dot at -1, close dot at 0. Okay, so it's between -1 and 0. So the way to do that is to put your -1, put your 0, put x in the middle, and then put your less than symbols. But then the one at -1 has an open dot, so we're going to not put a solid line underneath it. The one at 0 does have a solid dot, so we will put a solid line underneath it. Now for the last one, y equals what? Y equals -2/3 x minus 1. Let's write that down. -2/3 x minus 1. And then if what? Well, it's from here to the right. What x value is this? It's 0. So from here at 0 to the right. So I'm going to say greater than 0. Why not greater than or equal to? Because that's an open dot. So if x is greater than 0. So there's our piecewise function right there. Let's state now the domain and range of the above piecewise function. Well, the domain, we all know, are our x values. So does this graph go to the left forever? Yes. Does it go to the right forever? Yes. So what do we say the domain is? It's to the left and to the right forever. So you're going to say x equals all real numbers. How about the range? Is this whole graph below a certain value, above a certain value, or does it go up and down forever? This really does go up forever and down forever. So again, it's going to be all real numbers, but in this case, it's going to be the range, or your y values being all real numbers. Let's compare that to this next one right here. Let's go a little quicker on this one. So on this line, what's our slope? Up 1 over 1. So m equals 1. And where does it cross? It crosses at 1. So when I think y equals mx plus b, I'm thinking y equals 1x plus 1. I don't even need to put the 1 in front of the x. The slope is 1 over 1, so 1x plus 1. I could just leave it y equals x plus 1. Down here, where I go f of x equals, I want to put that first one, x plus 1. And what's the condition? If, where does this begin? It's not the whole thing. It starts here at 1 and it goes to the left. It starts at the x value of 1 and it goes to the left. So if x is less than or equal to 1. Why or equal to? Because it's a solid dot. Now this next line is totally flat. The slope is 0, which means that it would just cross. It's a perfectly horizontal line that would cross the y-axis at 1. So that equation is actually y equals 1. It's totally flat. It doesn't have a y equals mx plus b. If you wanted to, you could put y equals 0x, because there is no slope. It's totally flat, plus 1. But then it would still just be y equals 1. Anyhow, this line obviously does not go forever. It's a really short line. It's from here to here, from the x value of 1 to 2. So let's put y equals 1. So check this out. Here's y. Here's equals. Let's only put the number 1. That's kind of weird, huh? And then if the condition is it's between 1 and 2, all right? Between the x value of 1 and the x value of 2. So let's put 1, 2, put x in the middle, and put these. That would mean that x is between. Which one's solid? The value of 2 is solid, so let's put a solid line underneath that one. Moving on to the last one. What's this line going to be? Well, you need to extend it to see what your b value is going to be. It looks like if we extended it correctly, it goes 2 this way, 1 up, 2 this way, 1 up. It would cross right here at 1. So my b value is 1, and my slope is down 1 over 2. So my slope is down 1 over 2. So I'm going to have y equals down 1 over 2 with an x. And we said it would cross at the b value of 1, at the y-intercept of 1. So let's put plus 1. So the last one's going to read y equals negative 1/2 x plus 1. Y equals negative 1/2 x plus 1. Negative 1/2 x plus 1. What's the condition? If what? Well, where does this line begin? It's not anywhere over here. It's from here to the right. This is at the value of 2 to the right. So we're going to put if x is greater than 2. Why didn't I put or equal to? Because it's an open dot. I have my piecewise function complete right there. I hope you understand it. Let's state the domain and the range. Now the domain, does it go to the left forever? Yes. Does it go to the right forever? Yes. So what's the domain? Again, the domain is x equals all real numbers. Now how about the range? Does it go up forever? No, it doesn't. This is the highest point in the whole piecewise function graph. This is the highest point. The whole entire graph is at this point or below. It never goes above. There's no arrow pointing up. There's no arrow pointing up. This is the highest point there is, and everything is below. So we're going to say the range is y must be at 2, because that's the highest point it goes, at 2 or below. So how do I say that? Y must be less than or equal to 2. Ladies and gentlemen, that's barely the front page. I did give a thorough explanation on every single one. I hope you guys didn't just watch this video, but try to do it on your own. We'll be uploading another video on page 2, and then another one on page 3, and another one on page 4.